Hi guys, I'm ready with Wednesday's video. Remember, you're on your worksheet that you brought home, and I'm just going to go through some examples of, I think it's number 6 through 9. And first you are being asked to just solve some equations, and I know you know how to do this. We use this in geometry all the time. So just remember, everything balances at the equal sign. We're trying to get x by itself. So we start by adding 4. You end up with 3x equals 18. Then you've got to divide by 3, and x equals 6. Just remember your inverse operations. Remember that you're trying to get a variable isolated. Okay. The second type that you have, if you notice, it has a variable on both sides. If you're looking at the balance of the equation, it's got an x on each side. So I want to move this 4x. I'm going to take off this 4x and move it over here. Okay, so I'm going to take off 4x from here, and then I have to take off 4x from there. So I end up with 6x. I'm going to rewrite 6x minus 5 equals 19. Okay, now I've got to undo this subtraction here, and I undo subtraction with addition. So I'm going to add 5 to both sides. So I have 6x equals 24. Okay, and then the last step, I've got to undo this division, or undo the multiplication with division. So I'm going to divide by 6, and I end up with x equals 4. Okay, I know you guys are good at those. That should be easy for you. Okay, so the last two problems that you have to do with systems of equations. A system is just whenever you have two equations that go together, they have more than one variable. So if you look, these both have an x and a y, and we're looking for the x and the y that makes both of these true. So there's one way that you can solve it, and it's by graphing. And if you notice, it's really easy to do graphing. If they're both already in slope-intercept form, I can graph them easily. Remember, slope-intercept form is y equals mx plus b. And so I'm going to start with the y-intercept, which always is here on the end, which is minus 8, negative 8. So I'm going to go to negative 8 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to mark my y-intercept just like we did the other day. Okay, now the slope would be the number that sits right here in front of the x. When there isn't a number there, we know that that's a 1. Okay, so I'm going to, if I stick a 1 in there, and I know that as a fraction, that would be 1 over 1. So if you're looking for your rise over run, I've got 1 over 1. So I'm going to start here, down here at my y-intercept, and I'm going to rise 1, run 1. Rise 1, run 1. Rise 1, run 1. So here is this line here. Okay, and then on the same graph, I'm going to graph the other equation in the system, okay, which is also already in slope-intercept form, so super easy. I want to look here on the end and find my y-intercept where I'm going to start, which is positive 1. So I'm going to go on the y-axis and mark a positive 1. Okay, and then I'm going to look here right in front of the x to find my slope. Well, this is telling me the slope is negative 2, and I know that I need it to be in fraction form so that I can see the rise over run. A negative 2 is just a negative 2 over 1. Okay, when you have a whole number, you just have to put it over 1. So I know the rise is negative 2, the run is 1. So I'm going to start here, and I'm going to rise negative 2, run 1. Negative 2, run 1. Negative 2, run 1. Negative 2, run 1. Okay, and what's going to happen if it's a system, what's going to happen is that they're going to intersect, okay? And this point where they intersect, this ordered pair where they intersect, that's the x and the y that's going to satisfy this system of equation. That's going to make it true. So your answer is going to be the ordered pair where they're crossing. So we see this point right here where they're crossing. Okay, I'm going to circle it, and I need to figure out what is this ordered pair. So I'm going to start back at the origin, and remember, an ordered pair is x comma y. Okay, like we talked about in the very beginning. An ordered pair is x comma y. So I'm going to start at the origin, and I'm going to count over 1, 2, 3, and then down 1, 2, 3, 4, 5. So this is crossing at 3, -5. So my answer to this system is where those two lines crossed, which is at 3, -5. Got it? You guys did this in Algebra 1, but that's why we're doing a little bit of review so that you guys are ready to start in Algebra 2 in the fall. Okay, the last example on your assignment is asking you to solve a system of equations using elimination. Okay, and this is something that you did learn in Algebra 1. Eliminate, if you think of elimination, elimination means to get rid of something. So when we've got the two equations stacked on top of each other and they're both in the same order, these are both in standard form, we're looking for something that we can get to cancel out. Okay, and so I'm looking and I see that if this was a 2x, then I would have 2x minus 2x that I could get to cancel out. So what I want to do, I decided that I want to make this a 2x because that way I can get it to cancel out. I can get it to eliminate. Well, if I'm going to make this a 2x and multiply it times 2, that means that I have to multiply the entire equation by 2 in order to keep it equivalent. So I'm going to put parentheses around the whole thing. I'm going to multiply that whole entire thing by 2, and I'm going to rewrite it down here. Okay, so what I'm doing is I'm multiplying all of this by 2 because I want to find something that will cancel out. All right, my goal is to get something to cancel out. So here I'm going to multiply this whole entire equation by 2. So 2x plus 6y equals 12. Okay, so first step is I got something to match up here. I got a 2x and a 2x. Now I have to ask myself, to get those to cancel out, to get that x to eliminate, do I need to add them or do I need to subtract them? And the answer is, in this case, I need to subtract them because I'm trying to eliminate. So if I'm going to subtract, again, I have to do the same thing to everything. And now I'm going to start looking up and down. I have these stacked on top of each other for a reason. So when you're writing this down as you're following along, make sure you've got this stacked up. The x is on x, y is on y, and then the c on c. Okay, so subtract. I'm going to subtract that to get it to cancel out. I'm going to have to subtract this, and I'm going to have to subtract this. So I want you to put a minus sign in between all of them, and then we're going to draw a line here. And remember, we're looking from top to bottom now. So 2x minus 2x does exactly what we wanted it to do. It cancels out. We eliminated that. That was the goal. So now I've got negative 7y minus 6y. So negative 7y minus 6y is going to give me negative 13y. Okay, and then I've got negative 1 minus 12 is going to give me negative 13. So then when I divide by negative 13, I'm going to get y equals 1. Okay. Now I'm not done because remember I have to have an ordered pair. Just like we did whenever we graphed a system of equations, our solution has to be an ordered pair. So I'm going to take this y, I got y equals 1, and I'm going to go back up here and I'm just going to pick one of my original equations. I'm going to pick this x plus 3y. That was the original one that we started with. It doesn't matter which one you pick, but you pick one. Y equals 1. I'm going to use a 1 in place of y. Okay, so I'm going to go over here and I'm going to put x equals 3, or x plus 3 times 1 equals 6. Okay, so what I did is I took this original, that's why I underlined this part. This was the original one that I started with. Okay, now that I have an actual number value for y, I can go up here, put the 1 in for y, and then solve it. So I've got x plus 4 equals 6. And then I just subtract off the 4 to get x equals 2. Okay, so I figured out what y was by eliminating the x's. If I eliminate the x's, I can figure out what y is. And then I just took the y and went and put it back in there to solve. So my answer is going to be an ordered pair. Remember, x comma y. So 2 comma 1 and I'm going to put a box around it because that's my final solution, is the x and the y that would make those two equations true. Okay, I'm going to pause here. Okay, we're going to do one more solving a system with elimination because I know that that one might have been a little tricky, and it's probably been a whole year since you've done it. So remember, elimination means that I'm looking for something that I can get rid of. I'm looking for something that can cancel out. And so right away, I get drawn to this 8 and this 4 because I know that if I multiply the 4 times 2, that I can make it into an 8. So if I'm going to multiply this 4 times 2, I have to do the whole entire equation by 2. So I keep it equivalent. So I'm going to put parentheses here. I'm going to multiply this whole thing times 2. Okay, so I've got, and I'm going to write it. Remember, they have to stay lined up because when we go to eliminate, we want to have them stacked on top of each other. So I've got 6x, and I'm going to write it directly below, directly underneath here. 6x plus 8y equals 12. Okay, now I'm looking at these two, and I did what I wanted to do. I got two coefficients the same so that I can cancel them out, so that I can eliminate. Now I need to ask myself, do I eliminate it by adding or by subtracting? Well, I'm going to eliminate it by subtracting. Okay, so I'm going to put a subtraction sign here because I need to do 8y minus 8y, and that's going to cancel out. So I'm going to have to subtract everything. Since I subtracted the 1, I'm going to subtract everything. So I'm going to draw a line there. Oops. And I did what I wanted to do here. I got 8y minus 8y, which will cancel out. So I'm going to cancel that out. That's gone. I eliminated the y's. So now I can solve for x. So I've got 7x minus 6x, which is just 1x. So x. And then 10 minus 12, which is negative 2. So I end up with x equals negative 2. Now, once I've got a number value for x, I can go back up here to one of the original ones. I'm going to use this one. I'm underlining it so that you know this 2 was not part of the original. Okay, so I'm going to put in a negative 2 for x. So 3, where should I write? 3 times negative 2 plus 4y equals 6. Okay, all I did is I took this x is negative 2. I went back up here to my original, and I'm putting in a negative 2 in for x. Okay, you could do it in any of them. Okay, I just picked the first one because it's the first one. But you could go back and put a negative 2 in any of them to figure out what y is. So here we go. I've got negative 6 plus 4y equals 6. Okay, I'm going to need to add this 6 here, which gets that to cancel out. 4y equals 12. And then I divide by, divide by 4, and I end up with y equals 3. Okay, so my ordered pair that I'm going to write as my solution is going to be x comma y. So negative 2 comma 3 excuse me, is going to be my solution. Okay, and then that should cover you for number 6 through 9. So you can pause, rewind, listen to these examples again. Remember, if you want credit for your work, to have a picture of the front and the back sent to me by Friday night so that I can give you credit for your work. Alrighty, bye guys. Have a good weekend. I miss you, and I'll have another video up on Monday. You'll have another assignment starting on Monday.